तुम एक जगह वहां से कर लो ना। फिर आ जाइए, कैसे करो। गुड आफ्टरनून एवरीवन. Good afternoon, everyone, and my name is Dr. Shailesh Agrawal. I am Executive Director of Building Materials and Technology Promotion Council, and I extend a very warm welcome to all of you to this webinar series, uh, which we are starting today. Today is the inaugural, session, which will be taken by me on, Government of India's initiative with regard to innovative construction technologies which can help in fast development of built environment without sacrificing structural and functional performance. So I will be speaking to you in detail the technologies, the construction systems which are being promoted by Government of India, that is Ministry of Housing and Urban Affairs, which is my ministry, along with CPWD and with other state governments as well. And after this, we will be holding this webinar every month, preferably on last Wednesday of every month. And we will be taking up in each webinar a specialized topic related with green technologies, innovative materials, energy efficiency, thermal comfort, and other related topics. In case you want something else to be discussed, please do write to us, and we will try to, get the experts of those subject areas for you as well. And also there is one announcement, because we would be issuing to all of you who participate in this webinar a certificate of participation. So I request you uh, all to write your name along with your any affiliation. Suppose you want to write engineer or professor or doctor, or if you are affiliated to some department, and if you want that department name should also be written, or your organization name. So please do write in chat box. My computer team will take these names from here and send you the certificates. Okay. Also, the presentations which we will be making, like the presentation which I'm going to make to you. If you want a copy of this, you can always you can always respond to the mail through which you have received the link of, meeting link of today's webinar. We will try to send you the PDF version of this lecture. With this, let me start my lecture. And if any question, any doubt comes to your mind, you can always write it on in the chat box, or you can just, if time permits, we will be taking up question and answers in the later part of this webinar. So with this, let me start my lecture. I will just share my screen and ask one of you that whether you are able to see this or not. I hope you are able to see my screen. I request, yeah, okay. Please, most humbly, I request everyone here, everyone present here, to please switch off your video and also your mic, because it creates a lot of disturbance. Okay, and is my voice clear and legible to all of you? So you are able to hear me? Okay. Okay. So as I told you today,
little louder, please. Little louder, please.
Okay. Okay. Today's lecture, as I told you in the beginning, is on Government of India's initiative with regard to bring technology transition or technology transformation in the construction sector. What does it mean? That also I will explain the initiative which we take in 2019. That also I will explain to you in detail. So specifically, we have kept the name of title of today's webinar as technology transition through lighthouse projects. So there are two words in this. One is lighthouse projects, which were very ambitious, affordable housing, projects under Pradhan Mantri Awas Yojana, through which we showcased new construction systems for the first time in the country. Okay, so that I'll be discussing. And technology transition means all of you know that how do we do the construction? Normally, we do it cast in situ construction or load bearing construction, and through this effort of ours and the ministry's effort, we are trying to bring in technology transition. We are trying to replace cast in situ, frame construction, RCC frame construction, or brick and mortar construction by these, time tested and proven construction systems, like you might be knowing precast. Then there are drywall construction and whole. Please switch off please mute your mic. I request once again to all of you. And our effort, effort is to replace these systems by these new systems, because all of you know, most of the projects, earlier were caught in time overrun and cost overrun. Most of the projects were delayed, and because of delay, there is, enhancement in the cost. But nowadays, you find that most of the projects are completed well within time, whether it is infrastructure project or whether it is related with the roads and all, and it is happening because of new processes and systems being in place. So in a similar fashion, we want to bring in these technologies in the construction sector, so that we don't have time overrun and cost overrun, and also at the same time we bring in sustainability, climate resilience, thermal comfort, disaster resilience, and waste minimization, all of these things which are needed in today's context through these construction systems. So let me just start with giving you a few statistics. Just why do we require these new technologies? So you can see on the left hand side on your screen, what you see is a graph or a bar chart which shows you the India's urban population. So last census was conducted in 2011, and as per that census, 380 million means 38 crore people were living in urban areas. And if we look at the projection now, all of you know that pretty soon we are going to have census. But if you go by projections, there have been a number of reports. The most recent report has been from United Nations on world urbanization, and as per that report, by 2030, within 5 years, we will be 40% urbanized. That means 59 crore people will live in urban areas. And by 2050, 50% of India will get urbanized, and around to the tune of 81.5 crore people will live in urban areas. So you might be thinking why I'm telling you this. Just imagine all of a sudden from 40 million, 40 crores to 80 crore people living in urban areas. So that means there will be huge pressure on urban centers. We need to build the buildings, housing, and other related infrastructure. And if you see just below the graph, a rectangle, there was a report from KPMG which says that if you want to tackle this growing population, if you want to meet the aspiration of growing urbanization in the country, we have to build 600 to 800 million square meter urban space every year till 2030. That means new Chicago city has to be built every year. And can it be done the way we do our construction? All of you know that the prevalent construction practices as of today, particularly in the housing sector, are slow paced, because primarily they are cast in situ, dependent on labor, dependent on material, dependent on the weather, and whole host of other things. And that is why construction normally takes more time than what is envisaged. And on right hand side, what you see, a whole lot of bullets you see. I just wanted to, apprise you that we all, being Indian, should feel proud that India is, India is very fast progressing, and right now we are fourth largest. In this first bullet I have written fifth, but now India is the fourth largest economy in the world, and we are one of the fastest growing economy. And also, we would be, we are aspiring to become 30 trillion economy by 2047. And construction sector, which is our sector, is going to play the most prominent role as far as economy is concerned, and it may touch to 1.5 trillion by this year itself. And construction sector being largest employer of workforce, so whatever we do in construction sector, it has to be innovative and productive. We need to foster sustainable growth and ensure better quality of living. And that is why we are trying to bring technology transition, trying to replace conventional system by new systems which are innovative, which can help in sustainable development as well, and ensure better quality for the citizens of the country. And the last bullet, just to make you aware that we are following a 3S mantra, and 3S, these 3S stands for skill, scale, and speed. So as all of you who are gathered here to listen to me, please understand that skill, we need to constantly upgrade our skills. Suppose you are engineer, so that's not the end. You need to upgrade, because the time I did my engineering, and as of today, the entire civil engineering has changed. And a whole lot of new things have come. Like when I studied, there was nothing like softwares and all. There was no introduction to computers, even when I did my BTech. But now everything is being done through computers. Even drawings we used to make with T and set squares, and slowly they were replaced by mini drafters, and now everything is being done AutoCAD. So, dear participants, you need to, if you want to keep yourself meaningful, you need to keep yourself abreast with latest developments happening in all spheres of life, not only in your field, but in all spheres of life. And for that, you need to constantly strive to upgrade your skill. And just to mention, Government of India is also running a Skill India program. And what is the tagline for that skill? Skill, upskill, and reskill. Means you have acquired some skill, then upskill, add something else to it so that your skill is upgraded. And that is also not the end. Again, you reskill yourself with something else. So it's a constant process of upgrading your skills all the time. Second is scale. The kind of skills we are dealing with. As I just told you, the kind of urban population we are 80, we will be 82 crore people living in urban areas. All of India is the largest populous area. We just in 2023 itself, we have beaten China as far as population is concerned, and around 1/7 of world population live in our country. So whatever material, whatever technologies we think of, or any process we think to promote or to mainstream, we should always think of scale. And the scales which we are dealing with are unprecedented, unheard, and nowhere in the world these kind of scales are being dealt with. And third is also very important, speed. As engineers, architects, and policymakers, please take it from me. If you want to contribute to nation's growth, if you want to contribute that India should become a $30 trillion economy, and all of us know that our Honorable Prime Minister has given a clarion call that by 2047 we should become a developed nation. So we have to move pretty fast. moving pretty fast means we have to build our built environment pretty fast. So for that we need to bring in speed as one of the parameter while selecting any material, technology or process. So most of the time when we take up any project related with buildings and infrastructure, we think of cost per square foot or cost per square meter, and we take time for granted that it will take at least 18 months or 24 months. But now that will not be the case. You need to complete the work within a limited time span. So say let's reduce 18 months to 12 months. So that reduction of time will decide the kind of processes, construction systems you are going to use. So please take it from me, whenever you embark upon a new project or whenever you try to adopt any new system, new technology or any building material, think of the speed, in what way you can reduce the construction time, or in how you can expeditiously deliver the project you are assigned. And just to give you an example, all of us know that right now, earlier we used to lay around 20 to 30 kilometers road per day, and nowadays it is just doubled. So it has happened because of technological interventions. And they know yesterday only there was a circular from Ministry of Road Transport that the works which are more than 300 crores, they need to use precast components and products for the infrastructures being used in the road. Okay, so skill, speed and scale. Now let me just since I was talking to you about the scale, and whatever I'm presenting to you, it is the part of Pradhan Mantri Awas Yojana, and I represent Ministry of Housing and Urban Affairs. My department, Building Materials and Technology Promotion Council, comes under Ministry of Housing and Urban Affairs, and we are entrusted with the task to promote technologies on behalf of Government of India or on behalf of Ministry of Housing and Urban Affairs through Pradhan Mantri Awas Yojana. So as I told you, I wanted to tell you the scale. So just look at the scale, the number of houses we are dealing with in Pradhan Mantri Awas Yojana. Yeah. Anyway, let me also tell you, today is 25th June. So this Pradhan Mantri Awas Yojana was started on 25th. So today is the anniversary of Pradhan Mantri Awas Yojana. In fact, this is the 11th year. This scheme was launched on 25th June 2015. And in a span of 10 years, we have, delivered 90 lakh houses. 90.57. So you can see this is the updated data of day before yesterday, and we have already delivered 90 lakh houses, and already beneficiaries are living in these houses. So this is again it has been said in various forums that this is one of the largest affordable housing program because of its magnitude and implementation in the world. Nowhere in the world you will find these kind of houses being constructed. So we have sanctioned to the tune of 1.2 crore houses, and out of which in a short span of 10 years, 90 lakh houses have been successfully delivered to the beneficiaries, and they are already these houses are already occupied, and beneficiaries are living in these houses. And just a few other stats which I will not be covering, but you can see the huge even housing program requires huge investment. You can see the total financial outlay is 8.15 lakh crore, and this is to be shared with the state and central government. So already 2 lakh crore has already been committed, and it has been released. And there are few components. I am not going into that. If you are interested in these statistics, you can always visit Ministry of Housing and Urban Affairs website. You just type PMAY urban in the Google, and you will get the name of our website, and you can get all these. This is the dashboard which is constantly displayed when you enter on PMAY website. So as I told you, this scheme was started on 25th June 2015, and last year again when this the government, the new government took over, they again announced that in next 5 years, from 2024 to 2029, another 3 crore houses are to be constructed, in which 1 crore houses for urban and 2 crore houses for rural. So in next 5 years, we are already committed to construct 1 crore more houses in the urban sector. I just didn't tell you, this was the data for this. The data which I showed you is for urban, Pradhan Mantri Awas Yojana urban. There is another component which is led by Ministry of Urban Development, that is Pradhan Mantri Awas Yojana Gramin. There they have already delivered. Please, please mute your mic. Please mute your mic, participants. So in rural development or Ministry of Pradhan Mantri Awas Yojana Gramin, already 3 crore houses have already been delivered. And in next 5 years, the target is to build another 20 million houses in rural areas. So just look at the scale, and because of climate change and because everybody is talking about sustainability, India is committed to become net zero by 2070. We need to reduce our emission intensity by 30 to 35%. By 2030, we need to, ensure 40% of our cumulative, energy production through non-fossil fuel based energy or renewable resources. So this time under Pradhan Mantri Awas Yojana, we are very aggressively, we are promoting climate change, greenhouse gas emission, thermal comfort, and net zero. So the houses which we are sanctioning, we are handholding state governments, and also, working with them so that they use alternative sustainable building materials and processes and technology, so as to have thermally comfortable houses and energy efficient houses, and also multi-hazard resistant construction. Now let me come. So this was all about the statistics, and now let me come to the today's topic. Actually, if you look at how does construction take place anywhere in the world, so you will find these are the two most prevalent construction systems all over the world. So what you see in the photograph on the right hand side top is the typical load bearing construction, which all of us are quite familiar with, because all of us have seen our,
to the subject Madam Star join Yeah,
Mr. Tamil Sevi, please, mute yourself. Okay, so what you see on the top most picture is the load bearing construction. So anywhere in India, if you go to tier 3 cities, or if you go to rural settings, or even smaller cities, you will find most of the houses are isolated houses and built either using bricks or blocks or stones. And so we have thick load bearing walls, and over that we have cast in situ RCC frame. So this is the most prevalent construction system, and this system is called load bearing construction system, because here the load, dead load, live load, and other loads are transferred through these walls. Okay, that is why it is called load bearing walls. And slowly this load bearing system is being replaced by cast in situ RCC frame construction, which you see in a photograph just below in the second photograph, which is just below the load bearing structure photograph. So this all of us are familiar with. We first make the skeleton of a building in form of beam and columns, and these beam and columns are cast in situ, where you put the you on the foundation, you just put the formwork, put the reinforcement cage, do the concreting, remove the formwork, and then you do the walls. The walls are filled with the infills. It can be brick, or it can be any other block or stone or panel, anything. So this is the typical construction, cast in situ frame construction. So we are trying to replace these two systems by new construction systems, which I will be explaining you. And the merits and demerits of these systems, all of you are very well aware of, but again, I will try to explain you the merits and demerits of the system. All of you know, and just I want to introduce here that instead of having this, instead of making this wall brick by brick, you can just have a, drywall, which is, made in the factory or in a casting yard, and just you can just put it on the already laid foundation. So there is no need to make, to create a wall brick by brick, do the plaster. Instead of that, you can, just get a wall from the factory. Like we have, panels, drywall construction or panels. And in a similar fashion, why to make columns and beam at the site, we can have precast columns, beam. In fact, we can have the entire module or entire room precast in the factory or in a casting yard or offsite. So let me again introduce another word, offsite. So let's take construction from on-site to offsite. So the work which can be done in under control condition in the casting yard, that can be done there, and then that can be brought to the site and assembled at the site. So typically it is called precast construction or pre-engineered construction. So those kind of things can be introduced in the construction sector, and you can understand, you can you can think of the advantages. There will not be any waste. You will get a quality product. You will use this energy intensive material, which are based on finite natural resources very efficiently. There will be, you can minimize the use of water. You can do everything pretty quickly and in a very neat and clean manner. So let's replace these two systems, which are prevalent across the world, across the country, by new innovative systems. Okay, and as I told you that, and also this is called business as usual approach. So this is business as usual approach, man. This is the prevalent approaches, which is which are in practice in the country. So if we continue to continue to use this business as usual approach, we will have time overrun, cost overrun, sustainability is being compromised. We will have more greenhouse gas emissions, then a whole lot of other things as well. So some of the demerits of these systems, if we continue to follow business as usual approach, all of that we are too much dependent on cement, aggregate, and water. And all of sand is scarce, water is also scarce because we use potable water for construction. And I don't say don't use cement, steel, aggregates, but use them optimally, use them under highly controlled condition. And all of that when we do construction on site, or when we undertake any cast in situ project, how we mix water, how sometimes cement aggregates are being mixed. So let's use cement, aggregate, and water optimally. Let's consider them as precious commodities. Let's not take that cement, water, aggregates are available everywhere, because already you go to Tamil Nadu, you go to Himachal, in most of the states, sand mining is prohibited, and some of these states, they don't allow sand to be used. And like in Tamil Nadu, I know there you have to use quarry dust. You can't mine the sand there. And similarly in other southern states, you don't get sand. So also I always give the example of manufactured sand. We in my time, 40 years back, 45 years back, we never thought that sand will not be available. Sand, all of us used to think it's a natural material which is available everywhere. And all of a sudden today we don't have sand, and even all the cement manufacturing companies, they are into sand production. So that is called artificial sand production or manufactured sand. So this has happened because we have used sand the way we wanted to use, and that is why sand has become scarce. In a similar way, even coarse aggregates are in limited quantity, and nowadays we are talking about artificial aggregates. Artificial aggregates made from waste materials like fine fly ash and other slag. Fine aggregates are being made. C&D waste can also be used to make fine aggregates. So that is why we need to switch from business as usual approach to these innovative approaches, where we use all these precious materials like cement, aggregate, water, steel optimally. Also, the COVID time, all of us have gone through the difficult time. of pandemic, and that time, being from Delhi, most of the projects here came to standstill. There was a huge migration of workforce from Delhi to their respective native places. So, I'm being told that every project, all turnkey projects nowadays, they constantly face a shortage of skilled workforce. And that is why let's take the construction to the factories, to the casting yards, where let's industrialize the construction. Let me say it another way: let's industrialize the construction, where you can do everything using sophisticated equipments and the machinery, and you get the product, building component or building product made, and assemble them at the site. Okay, so, and third, as engineers, as architects, again, I can give you the example of my education. When I studied my civil engineering, there was no concept of green buildings, and now everyone is talking about green buildings, sustainability. And so any work which we do has to be green, sustainable, in line with the keeping in mind planet Earth. And all of you know that Government of India has started a mission called Life Mission, and that life stands for lifestyle for environment. So it's not only about construction, but our day-to-day activities need to be aligned with the nature. Everything has to be done in sync with nature. So, and same is the case with construction. So any construction you do, it has to be green construction. So we are talking about low carbon construction. We are talking about energy efficiency. We are talking about wastewater utilization in construction sector. We are talking about use of renewable resources like solar and other things for electricity generation. We are talking about these industrialized building systems or precast or pre-engineered construction system, which can help us in minimizing the use of these energy intensive material, minimize the use of waste. Also, these innovative construction systems can help us in multi-hazard resistant construction, because India, we have several hazards, natural hazards, so we need to construct structures which are safe as well. So all of these things can be brought in when we use these innovative construction systems. This I already explained you, that business as usual approach, which I explained you in my first slide, load bearing and cast in situ frame construction are slow track construction. And let us replace this slow track construction system by fast track construction system. So fast track construction system means let us reduce the construction time, or let's expeditiously or construct fast. Okay. And as regards green, because green buildings or sustainable development is being talked about, there have been several reports. So there is a report from the Energy Resource Institute, which says that buildings consume 40% of energy, 25% of water, and 40% of natural resources. And at the same time, buildings activities contribute 50% to air pollution, 42% to greenhouse gas emission, 50% to water pollution, and 48% of solid waste are being generated from buildings. So you can see, on one hand, buildings consume precious energy sources. This is the global consumption. 25% of potable water and 40% of natural resources, are built environment. And at the same time, they pollute air, water, and greenhouse gas emission and solid waste. And that is why we are talking about solid waste management, we are talking about municipal waste management, we are talking about C&D waste management and all these things. Okay, and as I told you that India is committed to bring down its emission and intensity. There is something called NDCs. NDCs are nothing but nationally determined contributions. So after Paris Agreement, just to tell you that all the countries, every year they gather, they deliberate on climate change issues and then commit and then put up some common targets, and those targets are given to each countries, and all the countries are committed to achieve those targets. So in a similar fashion, India is committed to reduce its greenhouse gas emission, to reduce its, to be net zero country, and to reduce GHG emissions, as I told you. So for that, and in the beginning, I told you that construction sector plays very important role. And since we are using 40% of energy, and at the same time around 40% greenhouse gas emissions are being done through buildings, so we need to bring in new systems, new technologies, new processes, so as to bring down these things, and so as to achieve what India is committed to reduce its emission intensity of greenhouse gas emissions. Okay. So as you can see, India is committed to reduce greenhouse gas emissions by 45% by 2030 and carbon neutrality. So in order to achieve these things, construction sector will play very important role, as you can see from this slide, and we have to resort, or we have to employ these new construction techniques. In a nutshell, if I need to compare conventional systems with these innovative construction systems in bullet form, you can see it is written here. Most of the things I have explained, but again, quickly I'll explain you slow and fast. You can understand. Instead of doing construction at the site, if you do construction in the factory, naturally you can achieve speed, and you can deliver the projects pretty fast. In fact, the precast concrete construction, pre-engineered construction systems can reduce the construction time by 30 to 50%. Okay, and I will show you a few films where within a short span of 1.5 months to 3 months, the entire building is constructed from the foundation to finishing to finish. Similarly, natural resources, as I told you, that cement, steel, concrete, aggregate, all these, conventional construction system, there is no control. But when you use innovative construction system, you can use these resources optimally. Waste, you minimize waste here without polluting air and land and water. And conventional systems are labor intensive, highly dependent on labor, but alternate systems are industrialized building systems, because they are based on assembly line production. And again, the question may come to your mind: by introducing these systems, are we reducing skill workforce? That is not the question, because there are a whole lot of new trades which are open when you use these innovative technologies. Conventional construction systems are based on certain thumb rules or prescriptive design. For a certain span, you will use certain depth, you will use certain reinforcement, whereas in innovative construction systems, all of them use customized softwares, and you get a performance-based or cost-effective design. Another very important aspect which we take for granted is indoor air quality. Whenever we do a construction, we always think that the construction will provide a good indoor quality, but that is not the case, because the kind of paints, varnishes, the kind of other things we use into construction, they create a unhealthy indoor environment. Okay, and through innovative construction system, you can at least create a better health. And if you create a better healthy environment inside your premises, that will definitely increase the productivity of occupants. In fact, there is a technology from UK. They produce panels, sandwich panels. It's a drywall construction. That panels are called MGO panels, and the company claims that MGO reacts with the carbon dioxide of the environment, thereby creating the better, indoor air quality. So you see the kind of thinking going on in the construction sector. A wall which can help you reduce the pollutants in the inside your premises. Okay, and all of you know, buildings, cast in situ buildings sometimes require regular maintenance, and most of the time, if you don't make the building up to the mark, if it is workmanship is not good, quality is not assured from the very beginning, you require regular maintenance, and on and off you will have certain architecture and structural defects, and all these things can be overcome when you use innovative building construction system, because in innovative alternate construction system, you are using all building components. They are being cast under strict under control condition and under strict quality control and under quality assurance. So another word I have introduced here is life cycle cost. So every, whenever we talk about any project, any new building, what question comes to our mind? What is the cost? And what is that cost? That cost is initial cost of construction. Do you think that is the only cost which is associated with the building? The answer is no, because that is the initial cost of construction. After that, the building will be there, will serve the purpose for which it is, constructed. Say that's for 50 or 70 years, the building will be in service. So during that 60 to 70 years, a whole lot of maintenance is required. Operational cost is required for, heating, ventilation, air conditioning, water, sewage, and other structural maintenance and architectural maintenance. So that is operational cost. So one is initial cost of construction, and another one is operational cost. So that cost we don't account when we talk about cost. That cost need to be accounted for. And once the service life of building is over, then how you are going to dispose that building, how you are going to dismantle that building, what would be the associated cost with that dismantling or disposal. And there is another cost. Once the building is disposed, are you going to use the material which is disposed again? Because when we talk about sustainability, nowadays we are talking about end of life also. So dear friends, please take it from me that whenever you talk about sustainability, it's not that you have used something and just throw it off. Once the product life is over, or anything which you have used, how you are going to dispose it? Is it degradable? If it is not degradable, can it be recycled? If it cannot be recycled, can it be re-engineered? All these things are to be taken into account if we want to create a sustainable net zero country. So all these costs, initial costs, operation costs, and disposal costs added together will lead to life cycle costs. So our aim, if we want to go for sustainable development, should be to, instead of having low initial cost of construction, we should minimize the life cycle costs. Okay, so building must have low life cycle cost if we want to bring in sustainability into our development. Then energy intensive, energy efficient, another thing, cast in situ, unless you assure the quality, unless you put strict quality control measures and assure the quality, you normally end up with poor quality. And here, because the construction or manufacturing of building components is done in the factory or in a casting yard under controlled conditions, so most of the time you get quality products. Okay, greenhouse gas emission I already covered, and all of these things together will lead to sustainable development if we use alternate systems, and if we use conventional, that leads to unsustainable. So this is in nutshell the pros and cons of using conventional versus alternate construction systems. And again, this is an acronym given by me. If you use these innovative, another word we have written is emerging. So the construction systems which are popular elsewhere in the world, or which are time tested and proven elsewhere in the world, we are trying to transplant those systems in our country and trying to adopt these construction systems for the betterment of our country. Okay, so we have given another terminology, emerging construction system, which are new to the country, and these construction systems can help us build safer structure. So SAFER is an acronym given by me, which stands for SAFER. S, you can say sustainable, A, you can say affordable, F, you can say functional, E, economical, R, resilient. Again, most of the time when we talk about these new technologies, a whole lot of questions are being raised about thermal comfort, sound, acoustics, water tightness, fire rating, and all. So let me tell you, all these new systems provide better functional performance, better structural performance. Okay, sustainability already we have talked about. So since you are using cement, steel, and all optimally, so they provide the resource efficiency and eco-friendliness, faster construction. If it is cost effective, then it will be affordable. Okay, and resilient is another thing which is very important in our country, because our country, if you look at the hazard profile, we are being visited by all kinds of natural hazards, earthquakes, landslides, thunderstorms, floods, high winds, cyclone, land subsidence, and whole lot of other things. So any infrastructure or any building or any house you make, it has to be disaster resilient, or it has to be hazard resilient, and it has to be multi-hazard resilient. Okay. So, so by adopting these systems, again, there has been a study by the Energy Resource Institute, TERI, and which says if you adopt sustainable measures, if you adopt sustainable materials, if you adopt sustainable processes and technologies, all these things can help you reduce the energy used by 30 to 50%, water used by 40%, greenhouse gas emission can be significantly reduced by 35%, and waste can be minimized up to as high as up to 75%. Okay. And this is again a very interesting slide to make you understand what I'm talking about. Okay. So whatever I explained you till now can be explained through this slide. So just I will, for a second, I will just keep myself mum just so that you understand this graphics. So what you see here, you see labels of construction technologies. Okay, labels of construction technologies means now try to find out at whenever you see construction, what kind of construction you see in and around you. So all of us will agree that label 0 will come to your mind, that any construction taking place anywhere in the country, you will select the site, you will hire the contractor, labor, you will try to get hold of the material, collect the material at site, do the excavating, form work, and all those things you will do, and then start construction. So that is level 0, which is the most primitive level of construction, or the most prevalent construction practices, where we try to gather everything at the site, take decisions at the site, and do construction at the site. So this is level 0. Level 1 is pre-engineered buildings. Again, I always give the example of industrialized building systems. Industrial buildings. So right now, nowadays, how industrial buildings are being constructed, all of you know that they are being made with steel pre-engineered buildings. So what you have ready-made steel beams, columns. They are brought to the site. You just construct a foundation. Over that foundation, you just erect those steel columns, and on steel columns you put the already made trusses, steel trusses, and cover those trusses and beam and column skeleton with puff panels or any other covering, profile sheets and all, and your industrial structure is ready. So that is called pre-engineered building on level 1. Nowadays, all airports, bus stands, all these things are done using steel or pre-engineered construction. So pre-engineered construction primarily means you fabricate the building components in the factory, primarily steel components, and then you just erect them with trusses and all, put the roof covering, and your structure is ready. So that is level 1, and level 1 is also quite prevalent in institutional or industrialized, in the industry. Cold storage you want to make any other installation, you can go for level 1. Okay, then level 2 is what you do, as I told you in the beginning, any building component. So what are those building components? Slab, beam, column, staircase, sunshade, or any other non-structural component, your shelf, your wall mountings, or everything, everything can be constructed under controlled condition in the casting yard, in the factory. So structural and non-structural components are cast in the casting yard, then brought to the site or transported to the site, and you just assemble them at the site to create the structure. So that is called precast concrete construction. So where you make the planar element. Planar element means the wall, the facade. So the wall, beam, column, slab, staircase, sunshades, all those components are made or cast in the factory or in the casting yard, and then brought to the site and you just assemble them to create your building. Okay, so that is called level 2, and it is called precast concrete construction. And level 3 is a notch above than level 2. Instead of making these planar elements, means instead of making 4 walls and a slab separately, you make the entire module uh, in one go in the casting yard or under controlled condition or in a factory. So the entire module, say the entire room, for example, you make transport it to the site and then just put one room over the other, or put one room adjacent to other to create your entire building. Okay, and that way you can create the building. So that is called volumetric construction, because here you are making the entire module. So it is the volume. And nowadays, you might have heard the word pod. Pod is nothing but what is bathroom or what is kitchen. It comprises of 4 walls and a slab. So the entire kitchen module you can make in the factory. The entire bath module or toilet module you can make in the factory or in the casting yard, and just transport it to your site and put it wherever you want. So that is called volumetric construction. There are several names to this. PVC is another name, and that way you can create the entire building. So that is level 3. In level 4, what we are doing, instead of making this, we make the module and do the finishing also at the casting yard. Finishing means you put the doors, windows, you can do the tiling, you can put the other services, plumbing services, the water services, everything in the casting yard. So 80% of the work is done in the casting yard. So it becomes a plug and play kind of module. So plug and play kind of module means you just once you transfer it at the site, install it at the site, you have to connect it with the services, water, electricity, and sewerage, and you can start using it. So up to 80% finishes are done in the factory or off-site or in the casting yard and brought to the site. Okay, so that is level 4. And our aim through this presentation, or Government of India through Pradhan Mantri Awas Yojana, we want to disrupt the construction sector by replacing this level 0 by level 3 and level 4. And level 2 also, level 2, level 3, and level 4. So our tagline is let's take a jump from level 0 to level 3 and level 4, and the associated advantages, the associated merits, which I have been talking to you from the very beginning. You will achieve all those advantages which I just discussed with you. Another thing I want to tell you here is that I will show you a few pictures here just to make you understand that these kind of things are happening in the country. And being from government, we have already showcased all of these technologies which I'm talking to you through demonstration construction, through lighthouse projects, which I will be discussing with you. I'll be showing you a few pictures. But before going into that, let me show you the kind of work going on in India using these technologies, the kind of speed they are achieving through a few video pictures, through some videos. Okay, let me just also tell you this, that now a few more things which are coming up. One is BIM. Some of you might be knowing about BIM. So BIM is nothing but a virtual model of your building, where you create a whatever you are doing at the site can be created virtually, and there is no need to go at the site. You can do real-time monitoring. All these stakeholders can pitch in virtually, and at the same time they can intervene. And so you create a BIM model, and through that BIM model you can achieve a whole lot of things which I talked about: sustainability, waste minimization. You can impart speed to the construction. You can achieve better quality and other things. Also, the word, whenever we do construction, what comes to our mind? Contractor. So a contractor will do the construction. And now that word is being replaced by DFMA. So DFMA is designed for manufacture and assembly. So there are specialized agencies which, as per your project requirement, as per your project site, as per your budget, they will set up a plant for you. They will manufacture the components for you, assemble those components, make the building for you, and then disassemble their plant and all. So that these are called DFM agencies, designed for manufacture, designed for assembly. And another word I have written is manufacturing of buildings, means instead of constructing a building, let's manufacture them. So when we say constructing a building, what comes to our mind? That we do construction at the site. So if we do construction in the factory, we are, it's called assembly line production. If you go to any automobile factory or any other factory, you will find this is assembly line production, where each assembly is assigned one task, and so you keep putting the components, and at the end you get the desired product. So in a similar way, you can create a building. So creating a building means you will have several components: beam, column, walls, and all those things. So in assembly line production, you keep putting those systems, and at the end you will get the entire finished building. Okay, so that is called manufacturing. So let's manufacture the buildings instead of constructing them. And PVVC is same thing which I showed you in level 3. So that is called pre-finished volumetric construction. There are agencies in India who are making, toilet blocks and kitchen pots. So kitchen pots and toilet pots, they can be pre-finished or without finishes. So they can be supplied to you. And the slide which I showed you is from a company called Home Mission. They are also trying to provide you any type of house at your doorstep. So you need to just submit your plan. So any type or anytime, anywhere, the house can be supplied to you. So again, that is called PVC or prefabricated volumetric construction. Okay, so another technology which is coming up is 3D printing. I will show you a few slides here, some videos here. So 3D printing is another technology. Let me just so there is no sound here, so here. So this is the first 3D printed building with the 3D printed post office.
USP is the speed. USP, if you want to bring this shape, it is not easy. With the 3D printer, any shape is possible. It's all controlled by laptop. Everything is controlled. We feed the drawing to the laptop, and it does the heavy.
A robotic arm, the concrete is being printed. So the printer is a robotic arm, and what is the print? What is the ink? That is concrete, specialized concrete. And this is the first post office building which was printed indigenously. And when Honorable Prime Minister inaugurated this post office building, he categorically said that each Indian should feel proud that India has successfully printed its first building. Let me take you to another video. This is the video which was shot by me. Again, a very small township at the Air Force Station in Chandigarh. The entire complex comprising of bungalows, comprising of officers' mess, comprising of office building is being done with 3D printing. So there is no sound here. So I will just try to explain you. This is shot from my iPhone. But you see here, this is a gantry girder. This is a gantry printer. This is a printing arm. this printing arm, the entire building is being printed. So sometimes it is said that you just can't print high-rise, 3 to 4 story buildings with printing. Here you see this is again an Air Force building. It's a mess and officers bungalow. 2-story building is being printed, and what you see here, there is a person here who is holding a tab, and through this tab he is controlling the movement of the printer. It's called layer by layer structure. It's called linear printer. So through this you create the concrete layers. This concrete is specialized concrete. Okay? And through this you can create the entire structure, and if you want to since it is a 2-story building, so you have to put reinforcement in the tree. Okay? And at one time you could just print 1 meter to 1.5 meter, not more than that. Okay? And then you can put the reinforcement. You can see it is so simple. So again, what you see here, the good thing is this is you can find the name of the printer. This is Marvin Automation Solution. This is the printer which is made in our country itself. So there are a number of companies in our country who are making these 3D printers and supplying it all over the world. I have come to know that Indian company has backed the project of 3D printing in USA. So this technology has so advanced in our country that our entrepreneurs, our agencies are taking up printing projects, 3D printing projects in abroad. So this is Indian printer. So this was about printing. Now let me show you another, again a Pradhan Mantri Awas Yojana project of CIDCO in Mumbai, done by L&T. 96 days, 96 houses were made from foundation to giving the keys to the beneficiaries. So 96 days, 96 apartments, high-rise structures using precast. Please see. What you see here lifted and put in the place. It's the time left for you. One floor in place. The casting yard. keys were handed over on the 96 days. So this is Government of India project under Pradhan Mantri Awas Yojana using precast technologies. Let me show you another one. This is again in 45 days, flight control system complex in Bangalore. Again, a project of Government of India, DRDO, executed by L&T. Here, instead of, they have used hybrid construction. So it is a mix of steel and concrete. Okay. So 45 days, the project was handed over. The entire complex was handed over by Honorable Home Minister to DRDO. Have a look. One-story building in 45 days. Hybrid construction. Finished building was handed over using hybrid construction in 45 days. Okay, let me show you another interesting one, a precast technology of, there is a South-based company called Teamage. During COVID time, there were a whole lot of news that other countries were making hospitals and other facilities within very short time. In our country also, a lot of structures, isolation wards and other things were created, and Teamage built a hospital during COVID time. In fact, it was a COVID isolation wards in 45 days using precast construction technologies. So foundation is conventional. They have used large panels, means the walls and slabs precast. Let's have a look at this. This came to a the road is just near to the So this was about the success stories. And just for academic interest, I will show you another film, because at Government of India and BMTPC, we are trying to address the doubts which are being raised by professionals. So one of the major criticism is that precast technologies do not perform good in earthquake-prone areas. So at MNIT Jaipur, a facility has been created where you can test the full-scale test can be conducted on any new innovative building system. So to address all these kinds of issues, we are constantly trying to find out through experimental investigations the answers. So our system of BG Shirke, which is primarily a precast concrete construction system, was tested. This is the first test in the country where a 3-story structure with precast was tested for earthquake loading in MNIT Jaipur. So I will just very quickly show you that. But if you have academic interest, you can get the details from me or approach MNIT to get the details. So just to establish the confidence and to know the seismic performance of these precast systems, the test was conducted.
BG Shirke.
So I'll just show you this.
BG Shirke Construction Technology Private Limited, Pune, being pioneered in India's prefab mass housing technology and having an avid interest in constantly updating and upscaling the technology with improvements in machinery, materials and design, reaffirmed seismic performance of their industrialized 3S prefab system through rigorous evaluation undertaken at National Earthquake Testing Facility, MNIT Jaipur. 3-level seismically vulnerable, full-scale 4-room segment at 16th, 17th and 18th story of 69.6 meter tall, 23-story building designed for seismic zone 4 with peak ground acceleration of 0.24 G and constructed using 3S prefab system, was tested for pseudo-static reverse cyclic loading in orthogonal directions. Experiments completed by loading the structure for 20 hours. The test house certified the ability of industrialized 3S prefab system to transfer earthquake loads of much higher magnitude than the design seismic forces through its distinctive connections, and hence the acceptable performance of the system is patently evident in seismic zone 4 for any number of stories.
You can see, so this test was conducted under the expert guidance of, Professor Murthy, who is the chairman of CD39, which is on the task of, revising the earthquake codes. And I was also involved. In fact, I was also witness to the entire proceedings of that test. And just to understand the behavior of precast building components during earthquake. So that is all about the films and all. And now let me just show you the technologies which we have been talking about. So as I told you in the beginning that the entire initiative was taken by Ministry of Housing and Urban Affairs under Pradhan Mantri Awas Yojana, and the basic premise was that Honorable Prime Minister was quite keen, or in fact he's quite keen to bring technology in every sphere of life. So in housing also, he asked us to bring technologies which can help build houses at a much faster rate, and the houses should be of quality, affordable and sustainable. So in 2019 we conducted a global housing technology challenge, and as you can see here, Honorable Prime Minister said that let's promote the use of new technologies in the housing sector. We conducted this global housing technology challenge so that emerging technologies should be used for low-cost mass housing projects. And you all can note down the website. This is a very informative website which is created by Government of India, where you will get all the details related with Global Housing Technology Challenge, the technologies which we have shortlisted. So I will just very briefly explain you. The initiative was to transplant new best global technologies for the Indian construction sector. And the challenge was to bring in construction systems from all over the world which are time tested and proven elsewhere. So it's not the new technologies for other countries. The systems, the processes, and construction technologies which are being used there successfully and proven, they are they we ask them to share those technologies with us, which can help us build, the houses, and infrastructure at a much faster rate without compromising structural and functional performance. So please listen to me carefully. Imparting speed without compromising structural and functional performance means the way we, the structural integrity or structural safety or structural performance should be better than the conventional construction system. And conventional construction system means the systems which are in vogue, which is load bearing or your cast in situ frame construction. So structural performance should be better. Functional performance should also be better. Functional performance means fire rating, thermal comfort, acoustics, water tightness, maintenance, and all those things. So we, through this global housing technology challenge, tried to study the technologies which are globally available. It was a huge success. It was organized in March 2019, 2nd and 3rd March, inaugurated by Honorable Prime Minister. And through this challenge, we shortlisted 54 new construction technologies or construction systems for the country, which I will show you here. So these are those construction systems, 54. And what we have done, just for the sake of clarity, again, a technology evaluation committee was formed by Ministry of Housing and Urban Affairs, which comprised of DG CPWD, with me as a member secretary, along with Director Housing for All as member secretary, and the representatives from public and private agencies, research laboratories, academic institutions, namely IITs and all. So 54 technologies were identified, and for the sake of clarity, we divided these 54 technologies into 6 broad categories, which very quickly, pictorially, I will explain you. And this is the nomenclature which is given by the committee. We called one category was precast concrete construction system 3D, where the entire module, instead of making planar element or beam and column separately, you make the entire module and put one module over the other to create your building. That is called precast concrete construction volumetric. Another category was the planar elements, where you make all building components separately and assemble them at site. So that is precast concrete construction system planar. So that is another category. The third category was steel structural system, hot rolled plus light gauge steel structural system. So replace RCC beam column or precast concrete construction by built up sections, and you can have a cold form steel if you want to, if you have a low rise structure. Then fourth category was drywall construction, or we gave the name prefabricated sandwich panel system. So I'll show you sandwich panel systems are a whole lot of sandwich panel systems are being manufactured in the country. You might be knowing about Aerocon panel. Then you have a fiber cement board, and in between you have a lightweight concrete. So those kind of panel, you all know about puff panel, where you have PPGI sheets, and a puff core is sandwiched between two PPGI sheets. So these panels can be used very effectively to replace your conventional brick wall or block wall. Then fifth was monolithic. Monolithic, again, name given by us because of this construction provides you monolithic structure. Otherwise, all of you know it with aluminum formwork or MAY-U construction system, where you have customized more aluminum formwork. Then last category was lost formwork or stay in place formwork, where the formwork is used as a formwork initially and then left in the structure to act as the part of the structure. So in each category, these are the technologies 4, 8, 16, 9, 6, 9, 9, and in total the technologies are 54. Okay, so I'll just show you.
Ministry of Housing and Urban Affairs, Government of India, organized Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector.
हमारे देश को बेहतर टेक्नोलॉजी क्यों नहीं मिलनी चाहिए? हमारे गरीब को लंबे समय तक ठीक रहने वाले घर क्यों नहीं मिलने चाहिए? हम जो घर बनाते हैं वो तेजी से पूरे क्यों ना हो? इसके लिए हमने ग्लोबल हाउसिंग टेक्नोलॉजी चैलेंज का आयोजन किया और दुनिया भर की अग्रणी कंपनियों को हिंदुस्तान में निमंत्रित किया।
54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies have been initiated by MAY-U. One of the lighthouse projects with 1,152 dwelling units in G+5 configuration along with all basic and social infrastructure facilities is constructed at Chennai. The construction process comprises of manufacturing of precast concrete columns, beams and slabs in MS molds. The final components are then transported to site, erected and installed by crane and assembled together through in situ jointing. The technology provides solution for low-rise to high-rise buildings, especially for residential and commercial buildings. The LHP constructed at Rajkot with 1,144 dwelling units in stilt plus 13 configuration using the technology monolithic concrete construction using tunnel formwork system. Tunnel form system consists of 2 half shells made of steel which are placed together to form a room or cell. Several such cells make an apartment. With tunnel forms, walls and slab are cast in a single day. The LHP at Indore with 1,024 dwelling units in S+8 configuration along with all basic and social infrastructure facilities is constructed at Indore. In this system, factory-made prefabricated sandwich panels made out of cement or calcium silicate boards act as wall panels. The panels having tongue and groove are joined together for construction of the building. In this project, steel structure frame is being used. This system is suitable for residential and commercial buildings and it can be used either with RCC or steel frame structure. The LHP at Lucknow with 1,040 dwelling units in G+13 configuration is being constructed at Lucknow using the technology Stay in Place or SIP formwork system. PVC Stay in Place formwork system being used in the project acts as pre-finished walls requiring no plaster and can be constructed with speed. This system is suitable for residential and commercial buildings of any height, from low-rise to high-rise. The LHP with 1,008 dwelling units in G+8 configuration, along with all basic and social infrastructure facilities, is being constructed at Ranchi using precast concrete construction system, 3D volumetric. Subject to the hoisting capacity, building of any height can be constructed using the technology. LHP with 1,000 dwelling units in G+6 configuration is being constructed at Agartala using the technology light gauge steel structural system and pre-engineered steel structural system. This light gauge steel structure independently is typically suitable for 1 to 4 story high buildings, especially for residential and commercial buildings. Lighthouse projects serve as live laboratory for further study, cross-learnings, adaptation and replication of the system in Indian subcontinent. The LHP will go a long way to reinforce the huge potential of technology pioneered in India.
So this was in a nutshell the lighthouse process. I will just explain you now. So so these are the 54 technologies which were divided into 6 broad categories, and whole lot of literature on these technologies are available on this website. So you can just note down this website name, and we also have a resource book on all the technologies which is written by us. You can download that book as well. Whole lot of presentation, video, audio visual capsules on all these technologies. 6 broad categories are available on our website bmtpc.org or on this GSTC india.gov.in website, or otherwise you can just type my name and go to a YouTube channel of BMTPC, and I have tried to explain all these technologies in detail along with lighthouse projects in pedagogy so that everybody can learn and understand. So these 54 technologies, we didn't stop here. We thought that we should showcase each category through actual construction of 1,000+ houses at different places in the country. And those 6 places where we did this construction, those projects were specifically called lighthouse projects. Okay, and that is why I explained you this. So these are those lighthouse projects: Indore, Rajkot, Chennai, Ranchi, Agartala, Lucknow. So each zone was selected, and everywhere under Pradhan Mantri Awas Yojana for EWS category, 1,000+ houses along with basic infrastructure were created at these 6 places. Okay, and these are the categories. I will just, because of procedure, I will just go very quickly. Otherwise, details are available. These projects were also projected as live laboratories where, we invited policymakers, professionals, students, press media, politicians to go and see artisans, to go see these technologies, study these technologies, and try to adapt them. So we are projecting these technologies as the future technologies for the construction. Okay, we have also started a scheme called Technograhi. So all of you can go to ministry's website and register, enroll yourself free of cost as Technograhi. So once you become Technograhi, we are calling Technograhis as change agents of innovative and sustainable construction technologies. And once you become Technograhi, you can a Technograhi module, e-learning module will be made available to you. You can go through that module to understand these technologies one by one, and then once you finish the module, you will be given a certificate of Technograhi, and you will also be connected with the ministry. So whatever is happening in the ministry, you will get to know their newsletters and the new projects with new technologies being undertaken by ministry and us. Okay, so this is the detail again. Chennai, Rajkot, Indore, Lucknow, Ranchi, Agartala. These are the houses, and as you can see, G+5 too. Again, because these are state-specific projects in different states, so each state had its own requirement. So the structural configuration varies from 6 stories to 14 stories. Okay, so per carpet area, project cost, and all those things are given here. And the picture which I showed you was showed to Honorable Prime Minister during the foundation laying. We conducted this challenge in 2019. 2020, the RFP was floated to award the 6 lighthouse projects, but because of COVID, the project could not start in 2020. 2021, foundation stone again. Foundation 21 also, it was a COVID time, so virtually for all the 6 states, you can see in this, along with Honorable Prime Minister and along with our Minister, the CMs of all the 6 states are present, and virtually the foundation stone was laid for all the lighthouse projects on 1st January 2021. And all these projects are now over except the project in Agartala, and Honorable Prime Minister has already handed over the keys to the beneficiaries. So I will just quickly explain you. This is a project at Chennai, where we have used precast technology. So here, just half a kilometer from the site, a casting yard was set up. The project was awarded to BG Shirke, and they have their own technology, 3S precast technology, where they make beam, columns, and partially precast slab. They are brought to the site, assembled at the site, and then they do the cast in situ jointing along with slab. So slabs are partially precast, and then you do the concreting to create a monolithic structure. So this is like this, and I will not go into the details. Fulfilling all the NBC requirement, this is the layout and all those things. These LHPs are not only the housing project, but we are providing social and basic infrastructure as well. So Anganwadis, milk booth, library, depending upon the requirement from the state governments. Then we have other sustainable features. All the projects are being rated under Griha, use of renewable resources like rainwater harvesting, solar lighting, solid waste management. All projects have STP and firefighting system. And all these lighthouse projects comply to the NBC, National Building Code requirements. So this is the thing. Again, you can see from this slide, so we are trying to replace these systems like this. So here, instead of this, we are making beam, column, slab, staircase, everything precast. Okay. So the only thing is foundation is conventional. Then you reach up to the plinth level, and from plinth level you start erecting these the precast hollow columns and beam, and then you do the cast in situ concreting to create a joint. Okay, so this you can see, this is the foundation, a typical isolated footing, and wherever there is less space, then we are providing a combined footing. So like this, you have the footings, and then over that footing, you put a stem column. Stem column is the column which connects the footing to the plinth beam. Okay, so again, these columns are precast, and then you have a plinth. What you see on the right hand side, those are the plinth beam, again precast, and then you do the through wet jointing, you fill the joint, and over this superstructure will come. So this is like this, beam, column, partially precast slabs, and to achieve economy, they have filled these empty spaces through infill walls, which is of AAC blocks. Okay, AAC blocks, all of you know, but I'll just explain you that also. Nowadays, few agencies, instead of AAC blocks, you can have a RCC wall also. You can replace the entire beam and column by RCC wall as well. So that is called a precast large panel system. So replace beam and column by RCC wall. But in this here, this is a patented system of BG Shirke. So there they have used partial precast beam, column, and slabs. Okay, now, this is how the slab is being placed, and this is partially precast slab. And what you see here is the space left. These are the U bars, and in this you will put the reinforcement of the partially precast beams, so as to have a monolithic jointing of column, beam, and slab. And this is partially precast, so over this you will put a nominal reinforcement, and do the screed concrete, so as to have monolithic construction. So this is how curing is being done, and this is that AAC block I was talking about. And again, just to show you casting yard, you must have got idea through the films, the casting yard setup. So in casting yard, everything is done through assembly line production. So you have big casting yard with molds where all building structural elements, building elements of that project are being cast with reinforcement. And some reinforcement bars are left so that they can be connected with plinth and other elements. Okay, so this is a typical setup you can see. Again, a precast beam, column, stairs being cast, and being you can see. So these are the once you have reached to the plinth, then superstructure is being created like this. The ground floor beam and columns you can see. Okay, and this is how once you have reached to a floor level, you can just cast in situ jointing is being done, and that is being done through self-compacting concrete, because the space is limited, so you can't have a conventional concrete. You have a self-compacting concrete, so you don't require a vibrator, and otherwise you can use micro concrete or non-string ground. And the beauty of this technology is because you have this is partially precast beam columns, and then columns are cast in situ, so it provides, this is called emulative jointing. So emulative jointing means it gives you a monolithic or structurally integral structure. So structural integrity is established, or monolithic behavior of structure is established. And monolithic behavior, why do we require? In case of an earthquake or lateral loads, the entire structure should behave together. It should have structural integral action. So because for that, this kind of jointing is being done. Okay, so this is before jointing, and after jointing, you can see these bars coming out. So this you do the concreting here. This is the slab I was talking to you. Partially precast slab are placed with bearing on beams, and once they are being placed, then you put a screed concrete of around 2.5 inch or 2 inch, 55 mm thickness is poured to ensure monolithic continuous action and ductile behavior of the structure. And then you do the curing. So structural integrity and monolithic behavior is achieved through wet jointing, or it is called emulative jointing. Fine. Then this is about AAC block. AAC block, again, we have a IS 2815. So depending upon the use here, because they are being used as a infill wall, so the density requirement is not much. You can use up to 500 kg per meter cube density block. So otherwise you can get this block as high as 1000 kg per meter cube. So this AAC block, all of you know, is a lightweight aerated concrete. Aerated concrete means you use foam concrete with cement, water. You can use either foam concrete or you can use aluminum powder to create this aerated block, and they are being autoclaved under heat and pressure. They are being cured, and the mixtures cement, sand, fly ash, and gypsum. So the AAC blocks are good alternate to burnt clay brick because they are excellent in providing thermal comfort, and you can get them in different forms. So here we have used 600 by 200, thickness is 150 for outer and 100 for inner walls. Plumbing and electrical services are as for conventional construction. So in a nutshell, this is the summary. Project was executed by BG Shirke, and what you see here, the casting yard, then from casting yard transporting the sections at the site, then assembly at the site, then doing the infill and putting the services. Okay, the entire, I have a 3-hour lecture on Lighthouse Project Chennai on our YouTube channel. So you can just visit our YouTube channel and get all the details. We also have a, compendium or a booklet which we created, which we published on this Lighthouse Project Chennai. So you can, which can be freely downloaded from our website or from ministry website, and you can see the details. So this project, again, despite of COVID and all, this project was completed in a record time of 1 year, and it was, given, keys were handed over to the beneficiaries on 26 May 2021. Let's move to the next project, which is at Rajkot. Here we have used tunnel form. As I told you that monolithic concrete construction can have different kind of formwork systems. One is aluminum formwork, another tunnel formwork. Nowadays you have slip formwork, jump formwork, table formwork. So here we have, since these projects were awarded through tender, and under monolithic construction technology, this tunnel formwork came L1. They quoted the minimum cost, so this technology was selected. So this is nothing but a inverted steel. This is customized formwork of a steel, and it creates a tunnel kind of structure. So this kind of tunnel is created. So it is a half L. So 2 L's are created, and then the steel formwork, and then you put the reinforcement, put the services, do the concreting, remove the tunnel formwork, and take it to the next floor. So that way you create the tunnel, and the other walls are infill walls, which are made with AAC blocks. Okay. So again, same thing here. These are the blocks and all. You can see GRIA rating and all those things, NBC compliance, and all those sustainable features, STP, solid waste management, rainwater harvesting, and all those things. So just to explain you, replacing the system by this kind of customized formwork, this customized formwork creates these kind of tunnels. Once you create these tunnels, you put the reinforcement, you do the, put the services and all, plumbing, electrical services, then do the casting of the entire area, entire floor in one go. Then within 1 or 2 days, you can remove this formwork, take it to next floor, and that way the entire, so that is why it is called tunnel. So it looks like this. When you remove the formwork, it looks like this, and these walls can be made with AAC blocks or any other material which is available. Okay. So you can see here tunnels are created, and then you can see. So here again, as I've been telling you, foundation for all these projects, or even whenever we are talking about new technologies, foundation is conventional, because in India we have different soil strata, we have different geotechnical profiles, different bearing capacity, water table is also varying. We have alluvial soil, we have rocky terrain, we have black cotton soil. So as per soil condition, water table, you can have foundation, conventional foundation. It can be pile, it can be isolated, it can be combined footing, it can be raft foundation. So here in Telform, this kind of raft foundation is being given. Okay, so a raft foundation requires heavy reinforcement, and this like this you can come up to the plinth level, and at the plinth level you leave some double bars, and then you create this kind of tunnel. Okay, so these tunnels are being created, and then the reinforcement which is coming out from the plinth and the reinforcement of the wall are connected together, and then the reinforcement of slab is laid, and then services, plumbing and electric services are being put, and then the concreting is done. Once the concreting is done, the way these tunnels are inserted, they are removed next day, keeping the props there, and taken to the next floor. Okay, so you can see here. So like this, they are being put. So just to explain you can see here. So this is the way this is being removed. So once this is cast, this is being removed and taken to the next floor. Once you have taken it to the next floor, you will put another two these things. Then you will put the steel mesh here, put another wall here, which will not be L, which will be simple rectangular formwork, and then you do the concreting, remove the formwork, take it to the next floor. Okay. This is how it is being done. You can see then the placement of concrete. Then this is the kind of structure you get, and then you the rest of the walls, which are remaining walls, can be lightweight precast AC block walls. Okay. So you can see typical reinforcement of slab. This is the reinforcement of walls. Then this is concreting is being done after putting the surfaces and all, and you get a very smooth finish because this is a steel formwork. Okay, so this is the kind of formwork. This is the corridor, and this is autoclave block, which I told you in the beginning. Then this is how plumbing and electrical services are being put. So in this kind of tunnel formwork or aluminum formwork, you have to ensure that all these services are laid beforehand, and then only the concreting is being done. Okay, so this is in nutshell. Again, a compendium, the complete booklet of Rajkot project is available on our website, Ministry's website. You can get the entire detailed lecture of 2 hours on through our YouTube channel. The project was again delivered successfully to the beneficiary by Honorable Prime Minister on 19th October 2021. Next project was at Indore. Here we have used sandwich panel system. I explained to you sandwich panel system are nothing but where you have a lighter core which is sandwiched between two outer layers or sheathing. Okay, so those two outer layer or sheathing, it can be fiber cement board, calcium silicate board, or it can be precast concrete panel. It can be your profile sheet as well. When you see industrial structure, we use puff panel, so that is also a kind of sandwich panel. But for residential buildings, we use precast sandwich panel system having fiber cement board or calcium silicate board or partially precast panel. And the core can be of different kind. It can be expanded polystyrene. It can be lightweight concrete. Like Aerocon panel, they use lightweight concrete. This is a specialized panel called cement EPS panel, where outer layers of sheathing are calcium silicate board, and in between they have elevated concrete. And elevated concrete is nothing but where you have cement, sand, fly ash, and aggregate is replaced by EPS beads. So these are factory-made, sandwich panels, come in a customized form. So they have around 1.2 meter width, and then the height in a specified height and tongue and groove arrangement. So you can create the entire wall using this. Since it was a high-rise structure, so we could not make the structure using only panel, because these panels are not load-bearing panels suitable only for one story. So we use the hybrid construction. Hybrid construction means we have used built-up sections for beam and column, and then we have used a deck slab. Deck slab is nothing but you have a profile sheet, a galvanized profile sheet. You put a nominal reinforcement over this and do the screed concrete to create a slab. So it's a hybrid construction comprising of steel structure plus this sandwich panel system. Again, a layout. I'm not going into that. Again, same thing here, same features, and here you are using this. So skeleton is of steel, and the walls are prefabricated sandwich panel system. Okay, which is cement EPS panel system. I'll show you. Again, foundation is conventional. Here again, combined and RCC footing is being used, and this is that structure system I'm talking about. This is your deck slab. You can see here, and this is that EPS panel. So what you see, this is the special concrete, which is made of EPS granule. EPS is expanded polystyrene plus cement plus sand and fly ash, and then this core is sandwiched between two calcium silicate board. It can be calcium silicate board or fiber cement board, and this entire panel is made in the factory and given at the project site, and then using these panels you can erect these walls very easily, and one panel can be lifted by 2 persons easily. And since it has tongue and groove or slide and lock arrangement, you can just create this wall, and it doesn't require anything else except you can do putty or even paint portion. Okay, this is a typical setup. I'm not going into this detail because of paucity of time. So manufacturing plant, and these are the typical dimensions. So again, these are customized as per your project. And you can see thickness is 50 to 250 mm. Length, length can be up to 2.43 up to 3 meter, but in this project the length was less, and the width is around 2 feet, so 610 feet, 61 centimeter was the width. Height of the panel was 3 meter. Thickness of the panel for exterior walls was 120 and internal wall was 90. And customized means as per your span size, and all these panels will be supplied when you have a room. So you will have L, T joint and all those things. So for T and L joint, for each joint, wherever you have two walls coming together, or you have a T joint, special cladding element and special elements are made and numbered and supplied, so that easily you can install those at those joints to create the continuous walling system. Okay. And this is how it is being done. I'm not going into that. You have to put a U-type channel. Then in this you have to insert this panel, and then you have to insert a bar to create connections between two panels. Because this is lightweight concrete, so easily a double bar can be steel double bar can be inserted through a groove, and if you have concrete, then directly you can connect it with the soffit of the beam and the face of the column. Otherwise, in steel you have to weld the steel double bar and then insert it into these panels, so as to create the entire structure together. And in case of any separation, the wall and frame will act together. Okay, so this is how it looks like. And finishes and everything is as per as you do in conventional. So this is a nutshell. Again, another thing I wanted to explain you here is that steel beam and columns are built up section. These are rolled I sections. Okay, so these are built up section, means you have three plates, and those three plates are cut and welded together to create an I section and then supplied to the site. Okay, again inaugurated on 5th October 2023 and handed over to the beneficiaries by Honorable Prime Minister. Let's move to the next project, which is of Lucknow. Again, it's a 14-story structure. Here we have used lost formwork. So I'll explain you that also. Lost formwork, again, being high-rise structure, this lost formwork can be used for G+3. We have recommended this up to G+3 story, but since it's a high rise, so again a hybrid construction is being used. Again, same thing here: steel beam, steel column, deck slab, and walls are stay in place formwork. Okay, same thing here. Again, so this is steel skeleton, and this is the kind of stay in place formwork system. So this comes in this form. You can insert bars here, and then later you can fill this cavity with lightweight concrete. So here in this project, the cavity is being filled with M15 grade concrete with bars inserted. It is a stay in place. So again, as it PVC wall form means the shielding, or the outer layer is of PVC, and it is colored. So as per your requirement, it can be of any color you want. Again, customized, and comes from the factory. Again, having tongue and groove arrangement of certain width, and the height is as per your room height. And then you can just put them together, insert the reinforcement, do the concreting to create the solid wall. Okay, foundation again conventional. Here again we have used the raft foundation. From raft up to the plinth you reach, and then at the plinth you create a plinth beam, leave the double bar, and over those double bars you put the formwork and steel columns. Okay, so this is how it looks like. This is the deck slab, and this is that stay-in-place formwork. So what you should see here, this is PVC, which is gray in color, and it has these cavities here. These cavities can be filled. So you have cavities in both the directions. Okay, so this is like this, and in this direction also. So you can fill these cavities with lightweight concrete, and to impart more stability, you can put the reinforcement as well, and that reinforcement can be cast. You can put L and you can cast it with the slab to create monolithic action between wall reinforcement and slab reinforcement. Okay. So this is how these PVC formwork looks like. This is a typical setup, and I think yeah. So this is again for external walls. This is 126 mm thick, and for internal walls it is 64 mm thick. And you can see width is around 2 feet. Okay, and height is as per your requirement. And again, since these are customized, so T and L, whatever joints you have in your structure, all those special elements will be supplied to you as per your requirement. Okay, so I'm not going into this. It looks like this, and this is the no need to plaster and all. You get a beautiful finish like this. And conventional, you can have through chasing and like you do in brickwork. In a similar fashion, you can cut the chase, you can fix the electricity and plumbing devices, then do the concreting and cross services and all. So it looks like this. And again, the project was handed over. I will just show you this one more thing here. So you can see here, so these are the colors. This is the finished project, you can see. So this is PVC ball form, this is gray in color, and here this is yellow in color. So in different colors, you can get this formwork and create. So there are three colors we have used. This is dark gray, this is off-white, and this is yellow. Again, handed over to the beneficiaries by Honorable Prime Minister on 10th March 2024. Then Ranchi, again, this is the first time this 3D volumetric construction technology is used in the country. 9-story structure, and just adjacent to the site, a casting yard was set up where the entire module. So again, as per your project requirement, they divided the building components in different concrete elements. So bath pod, kitchen pod, then some H sections, some E sections, all of them were cast in casting yard and then put one over the other to create these buildings. So at each floor, you will put some certain pod elements, bath pod, kitchen pod, and some other elements, then put the partially precast slab, and then do the screed concrete with along with reinforcement, so as to create the entire floor together and to create integral action between different elements. So this is again volumetric construction for the first time in such a large number used in the country. Again, same thing. All those green features and everything is there, complying to NBC forms and all. So here you can see these systems are being replaced by this. So you can have this kind of modules being put one over the other to create this. And this is a typical module, steel module, where you put the reinforcement, do the concreting, remove the formwork, and your the 3D volumetric structure is ready. Just to show you, this is a picture taken from Home Mission, another company doing 3D volumetric construction. So you create a steel mold, put the reinforcement, do the concreting. So this is you can see this is the steel mold. This is a steel mold. This is a steel mold being put. Then you are putting the reinforcement, and then do the concreting, remove the formwork. Then this is ready. Then through trailers, you can take it to the site and just over the already laid foundation, you can create the structure. So you can see here, there are different. This is the steel mold. I will not go. I'll just show you if this film is See how it is being. How this 3D element is being made. Casting yard, you can have series of steel molds and create all elements together. You can see that. And here it is not pre-finished. Otherwise, you can have pre-finished model. Then you will put services. You will put tiles. You will do the coloring. You will do the windows and doors. Everything you will put together. You can see here. This is how this is the casting of slab. Because when you have 3D modules, create monolithic action, create the slab. This, over this you will put the slab so that all the modules are connected together. I think from this you are able to understand the entire sequence. Exactly in the same fashion the LHP Ranchi was constructed. Okay, so I hope you are able to understand what does it mean, and in case you want to take a deep dive, you can go to YouTube channel of us and see the details here. So again, this project was handed over to the beneficiaries of 2024. The last project is in Agartala. Unfortunately, this project is not over because the site given was inaccessible. It was marshy land, water was flowing, and also project is inordinately delayed. Here we have used light gauge steel structural system. Again, Agartala falls in the highest seismic zone, that is seismic zone 5. So again, hybrid structure, steel skeleton and deck slab, and the walls are light gauge cold form steel walls. Okay, so I will just explain you. Again, same thing here. It is a G+6 7-story structure, 1,000 houses, along with social and the basic infrastructure, same features. So you have this kind of steel skeleton, and then you have light gauge cold form steel. So cold form steel is factory made galvanized steel components, and they come in form of wall panels. So you can just put those wall panels, steel panels, and then you can cover them with the fiber cement board or precast. Here we have used precast concrete panel. So those precast concrete panels are being cast at the side, and then outer side you can put a gypsum board as well, and inner side also you can put a gypsum board to create a better structure. And then the space in between can be filled with sand or lightweight concrete. Here we are using lightweight concrete. Okay, or otherwise you can use mineral wool or rock wool. Okay. So again, foundation, since it was a marshy land, so it requires a huge foundation. Here we have used a pile foundation, and huge piles were used here, having 600 mm diameter, and as long as 20 to 24 meters long piles were inserted, having 2 feet dia with heavy reinforcement, because it's a watery land, and over that the entire structure is coming. Same structure as you can see, and this is the lightweight I was talking about. Okay, so these panels are supplied to you, customized to you at the site. You can just erect them, and then both the sites can be covered with sheathing, or the outer layers can be of anything. As I told you, precast concrete panel, or it can be fiber cement board, or it can be simple sheet, or you can have fiber cement board of certain thickness, then you can have gypsum board. So entire specifications are also given by CPWD. Then the space in between, as you can see here, here we are filling it with lightweight concrete or foam concrete, or you can fill it with the lightweight concrete or a usual M10, M5 inferior concrete, so as to avoid the hollow sound. Okay, so very simple. Again, hybrid structure with light gauge panels. Light gauge, just to explain you how they are being made. You have a galvanized steel sheet, you put it in a roller forming machine, and through roller forming machines, you create a very thin, sections, and those sections can be C, Z sections, trapezoidal sections, and those sections are then converted into wall panels, and through self-driven screws, you can put two panels together to create the entire wall, and to connect it with the RCC beam or the steel columns. So you have a C channel which is laid, and in that C channel you will put these panels, and with self-tapping screws or self-driven screws, you can erect the entire wall, and then this wall is covered from both the sides with the, as I explained you, fiber cement board or any other covering you want to use. Okay. So this is how you can see here. So there is a steel coil, and this is being converted into first it is converted into section, and then this kind of wall panels. Okay, this is what I was talking to you. This is how you can see here. So you lay a C channel, and then over that you put this, wall panel, and then through self-driven screws you can create the wall panel. Okay, I'm not going into this. And this is how, the lightweight concrete is being put in this. This is how it looks like. So it's a hybrid construction again. So you have a lightweight, light gauge steel wall panel, and your primary load carrying members are steel, built up steel sections. And here again, so as you can see here, so once before putting the coverings, you have to do the services, and these services, plumbing and other services, water lines, plumbing lines, electric lines, all those things can be put, and then you can put the covering, and then you can do the concreting here. So that's that is all about all the lighthouse projects. And then the BMTPC is also to educate the professionals. We are running a professional course on all these new technologies, where all these 6 categories are taken up separately. Each day 3-hour lecture is given by experts to make you understand the nitty-gritties of these technologies. This course is being run in association with the School of Planning and Architecture. So if you are interested, you can register yourself. There is a fees for this course, and the next batch we are starting from 4th of July. So if you want to register, you can register for this course, and it is a certificate course. Once you, again, purely online every day, we have classes in the evening, and the classes will run from Friday to Friday, 8 days, and the last day you will be asked to take an exam, a multiple choice question exam, which you can take anytime, and once you pass that exam, you will be given a certificate. So details are available on ICT website. Okay, I'm not going into this. Next batch is, so this is again an old slide, so but the next batch is from 4th July. So this is all from our side, and now I think if there are some, because I won't be able to take your questions one by one. So if you have written certain questions in chat box, I will try to take them, try to answer them as quickly as possible. Otherwise, what you can do, you can write, you have our email ID, you can write those questions. I will stop sharing first. Okay, so you can write those questions in the, you can write an email to us and pass on those questions to us, and then we can, try to answer. So let me just see, and how we are going to give them certificate.
We will send by email.
So I think all of you have written your name as well as your, if you want, your certificate to be prepared along with your affiliation. So please do write your name along with your affiliation. So whatever you write there, we will provide you the certificate through mail on your email ID. In case you don't receive that certificate, please do write to us. And also questions you can send to us. We will try to answer those questions. Again, another thing, this lecture, you will get a PDF copy of this lecture through email. But anyway, I'm writing the website name GSTC-India in the chat box. So you can go to this website and get the audio-visual capsule. This is the one website, gstc-india.gov.in. Another website is ours, bmtpc.org. So from these websites, you can you can extract the information about these technologies. Okay, so thank you very much. I will request all of you to please open your video cameras so that we can take a group photograph. And if this group photograph is good, we will send a copy of that group photograph to all of you. So I request all of you to switch on your video camera. और कोई announcement?
हम लोग आगे भी करेंगे, keep sending.
Again, my organizers are saying you keep visiting our website bmtpc.org. In fact, all of you who have attended this course, I will request my co-organizers to write an email to you whenever we organize such webinars again. I'm planning to organize this webinar every fourth Wednesday of a month. So we will communicate to you. In case you fail to get that communication, you can always come to visit our website bmtpc.org, and we see when the webinar is happening. So I think I will take one snap now. So with this, I think I don't find any questions here, and so with this, okay. Somebody has written that what is your take on this? 3D concrete printing leads to more and exaggerated use of concrete. No, this is not the case. In fact, there is no wastage of concrete because this is a special type of concrete which is being used here. And in fact, now a lot of experiments are being done to make this 3D concrete also sustainable concrete. So organizations like CVRI and other research organizations, IITs, they are working on making this concrete using waste-based material. So agro-based waste is being used to produce this special concrete for 3D printing. Okay, so in fact, in most of these technologies, because these are industrialized technologies, wastage is minimized. Okay, what is the allowable height? 1 meter for 3D printing?
Yes.
Yes. So allowable height, again, in 3D printing, the most important thing, because it's a layer-wise construction. So you have to make a concrete in such a way that it can withstand the load of those layers which you are adding together. Okay, so you can always customize, you can always design the concrete, but normally it is like you have for brickwork 1 to 1.5 meter. So similarly here, I think not more than 1 meter in one go you can print. Okay, so I don't find any other question here. So there is another question. Any innovation that you are looking for in the painting? My job is to, as I told you in the beginning, I'm trying to replace the construction system. You know, the load carrying system, load carrying structural system. So like replacing cast in situ construction systems by another structural systems. Okay, so I'm not working in the area of paint or other hardwares. So skeleton of your building, how fast it can be made, that is the whole premise of this lecture, and that is what we are working on. Okay, so with this, I think I'll take another picture. So thank you for joining us. In case you have some questions, please do write to us. And thank you for being part of this webinar, and hope to see you next time also. Bye-bye.